All right, ladies and gents, we're back for the second part of 2.4, I believe it is, on compounds. And this is going to be a real quick one because all we need to cover is naming of acids and bases. Bases are really, really easy because bases have a metal bonded to the polyatomic ion OH. And nothing changes. If you see that an element, if a compound ends in OH, it's a base. And the name is exactly like we talked about polyatomic ions. This is called hydroxide. So that doesn't change or affect anything about the naming. So say, for example, we have sodium, that's a +1, and hydroxide is a -1 polyatomic ion. Okay, so those charges are the same, so you just smash them together, NaOH. This is, name that one, sodium. Name this one, hydroxide. Okay, so this is sodium hydroxide, and that's a U. Looks like an O. All right, so that's as hard as it is for bases. Okay, now acids, on the other hand, are just a little bit more complicated. All right, so remember, an acid, I'm reading these, an acid is made of a hydrogen ion and any anion or negative ion. So it's any compound that begins with H except for H2O and H2O2. Okay. So here's some examples right here. HCl, H2SO4, H3O, H3PO3. These are all examples of acids. Okay, and in an aqueous solution, acids dissociate, which means they split apart into ions. All acids do, but there are some acids that are strong acids, and there's some bases that are strong bases that dissociate 100%. We'll get to that in just a minute. All right, so to name an acid, there's two ways to name an acid. There's your binary acids and your ternary acids. All right, so binary, prefix bi means two, so it's an acid made of two elements. So HCl is going to be an example of a binary acid. So to name this, the anion ends in ide. So this chlorine ion would be chloride. Okay. So what we do is we take that ide ending and we change it to ic. Okay. So now it's going to become chloric. Okay. And the way I remember that is acids are icky. Icky. Acids are icky. Now, if it's a binary acid, then we add hydro to this. So this is going to be hydrochloric acid. So that's the name of that first one there, hydrochloric acid. Okay, so say for example we had HBr. Okay, this is the bromide ion. Okay, bromide ion. We're going to take the ide off, make it ic. So it's bromic. And since it's bonded to just the hydrogen, it's just two elements, then it's hydrobromic acid. Hydrobromic acid. Okay, so if it's not bonded to just an element, then the only other thing it could be bonded to would be a polyatomic ion. And these next two rules are for polyatomic ions. Okay, so SO4. What polyatomic ion is SO4? Well, if you look on your polyatomic ion sheet, SO4 is going to be the sulfate ion. Sulfate ion. Okay? And so that applies to this rule right here. So if it ends in 8, if the polyatomic ion ends in 8, change it to ic. So this is going to be sulfate sulfuric acid. Okay, we don't use hydro on this one. So the name of the acid is just going to come from the polyatomic ion name. So when you hear, so this is, someone asked me the question in class, why do we have to have different, sounds like ate and ick? Well, it lets us know when we hear that, how it's bonded. So if you hear hydrochloric acid, well, if you hear it starts with hydro, then you know it's the chloric part is just a single element, the chlorine ion. But if you don't hear the hydro, like sulfuric acid, then you're going to know that it's just a polyatomic ion that the hydrogen is bonded to. So furic, you're going to think, oh, ick. So that came from 8. So sulfate ion. So it's H2SO4. So it helps the way that it's named to help you recognize what the formula would be. Okay. All right. So let's go to the next example, PO3. PO3, that's going to be the phosphite ion. Phosphite. Okay, so PO3 is phosphite. Let me make sure that is correct before I say any more. Yes. All right. So if it ends in ite, then the ending is going to change to us, O-U-S. Okay. So ite changes to us. So this is phos for us acid, phosphorus acid. Okay. So the way I remember that is the same. I ate an acid and now I feel icky. All night I was nauseous. Okay, so it helps remember the endings. All right, so we can go from name to formula now. Hydroiodic acid. All right, so it starts with hydro. So it's hydrogen bonded with just one element. Iodic, iodide. So if it's a binary acid and it ends in ic, we're going to change it to ide. So iodide comes from iodine. So it's HI, hydroiodic acid. All right, and on the next one, nitric acid. All right, so there's no hydro there, so that means that this is a polyatomic ion, ic. Okay, and the polyatomic ion ic, the original ending was an 8, so that tells us this is a nitrate ion. Okay, so if we look on our polyatomic ion list, nitrate is NO3, and it has a -1 charge. So since hydrogen is a +1 charge, we only need 1, so it's HNO3. It's going to be the formula for that. And then our last example here, bromous acid, us, OUS. There's no hydro here, so we know it's a polyatomic ion. So us comes from ite. So this is a bromide ion. Okay, so if we drag out our polyatomic ion list and look at bromide, that's BRO. It's not on your polyatomic ion list, but I'm going to tell you it's bromide. Well, let's just look it up. All right, bromide. See it there. Let's do bromide ion. BrO2. Okay, so see right here, BrO2. All right, so if we go back and it's a -1 charge, that's going to be important. All right, so bromite is BrO2. It's a -1 charge, so it bonds with hydrogen. So those have the same number, +1, -1. So it's just HBrO2. It's bromous acid. All right, so you see how that works, and you have some practice on that practice sheet that I gave you for that. The only thing that I want you to do is you're going to need to know these strong acids and strong bases by memory. And if you don't recognize this, this is from the reference materials. If you look on the same page that the mole map is on, in the middle column at the bottom, you're going to see the strong acids and strong bases. This is a list of those strong acids and strong bases. These dissociate 100%. That's what makes them strong. So if they're not on this list, then it's considered weak, a weak acid or a weak base. And what that means is that when, say, for example, HNO3 is placed in water, that means that 100% of this is going to ionize. So it's going to ionize in the water solution to H and NO3 ions. 100% completely ionize. Okay, and the same thing with the bases. Like if you had lithium hydroxide, when you put lithium hydroxide down in an aqueous solution or in a beaker of water, 100% of this is going to break up into lithium ions and hydroxide ions. If it's not on this list, it's considered weak. So that's it. That's it for the video. Please make sure you slap that like button right across the face, hit the subscribe, and hit that bell to be notified of any time I put up a new video. Bye.